should not fall for my trap. Just because it looks like a quotient does not mean you should use the quotient rule. You guys should have this kind of maturity. Well, hopefully the quiz will learn this. Will help you embrace this idea. Quotients do not demand quotient rules unless they're like genuine quotients. 2 over stuff is not a genuine quotient. It is 2 over stuff. You should use 2, pull out the 2 and use like chain rule. Way, way easier. And the first one, you can algebraically reduce. It's stuff divided by x, so you just reduce the power on each thing. Do algebra before you differentiate. Way, way easier. Sorry. I shouldn't be happy. I'm not rejoicing in your suffering. I really do want you to learn. Let's see here. Okay, so quotient rule. This one, though, I do need the quotient rule. No way around it. So derivative of sinh is what? Cosh. So this gives me cosh squared. And then derivative of cosh is sinh. So minus sinh times sinh, which is sinh squared, over cosh squared x. That's what comes from, as some of you were telling me, high d low minus low d high over low squared or whatever. Like Sleeping Beauty or something. I don't know what's here. Wait a minute, no. Is it Smurfs? I don't know. What is it? Cosh squared minus, nobody knows the Smurfs. Let's see, cosh squared minus sinh squared. Some things are better left forgotten. Cosh squared minus sinh squared. Oh, it's 1. So this is 1 over cosh of x. I'll emphasize you can pull the square out like so, which is just what? So the derivative of the hyperbolic tangent is the hyperbolic secant squared. So, I mean, one of your initial questions should be like, why are these hyperbolic trigonometric functions, right? Because, I mean, the more full title is hyperbolic trigonometry, right? These are the hyperbolic trig functions. You see why they're called this. They're so similar to sine and cosine, and yet so different, right? So this is a mystery, this interplay, which is only fully answered when you take complex analysis, if you do. But it will serve us well this semester as we investigate things. Now, I need to do an example for the derivative of inverse hyperbolic tangent, much like we did inverse tangent earlier. So what if you want to differentiate inverse hyperbolic tangent? How would you do that? Start with some name calling. Don't worry, it's the kind that's allowed in your house. Y equals to inverse hyperbolic tangent of x. I'm sorry if you were raised to not say stupid. I will say stupid at various points in this class. I'm sorry about that. Let's see here. Sorry, I think my uncle, he wouldn't let his kids say stupid. We don't say that in our house. It's like, but it's a good word. Sorry. Some things are stupid. You should call them stupid. If you don't have that word, what are you going to do? I don't know. So, differentiate, right? The derivative of hyperbolic tangent, we just learned. So, yeah, squared y dy dx, derivative of x, also known as 1, right? So solve for dy dx, what we got? Yeah?
This might be a really dumb question. When you're differentiating in respect to y, do you always differentiate implicitly?
Well, I'm differentiating, I mean, I have a tangent of y, right? I'm differentiating this equation both sides with respect to x, right? So because I'm differentiating with respect to x, that's an implicit derivative. And the chain rule demands I write dy dx there. In the contrast, the right-hand side just differentiates to 1. Or dx is 1 if you want to look at it that way. So you guys can tell me, on the basis of what's on the board, a little bit below there, right? Scratch out the x, put in a y. What do you got? So you see this is that, right?
1 over.
And this is 1 minus x squared in our current context, right? Because tangent of y is x, right? So the derivative, this is 1 over 1 minus x squared is what I'm trying to tell you. So we have the following identity. d dx of the inverse hyperbolic tangent of x is equal to 1 over 1 minus x squared, which is a pretty sweet formula, I think. So who cares? Well, here's an example. The integral of dx over 1 minus x squared is equal to what? Right. Now, when's that true? Now, what's that amount to? That amounts to the question, what's the range, right, of the hyperbolic tangent? What is the range of the hyperbolic tangent? I didn't draw that one. In other words, what's the graph of the hyperbolic tangent look like? Look at this formula here. You can see a lot from this formula. As x goes to, and there's another formula, right? See that? These, I'll put them in a bubble. This formula and this formula are extremely useful to think about the graph. As x goes to infinity, e to the x, e to the 2x, and e to the 2x, these are ginormous compared to minus 1 and 1. So essentially, this function asymptotically just goes to e to the 2x over e to the 2x. So for very large positive values, hyperbolic tangent is just going up to like that. It doesn't get to 1, but it's going there. For very large negative values, e to the minus 2x is dominant. And so if you look at this ratio, it's going to minus 1. And so that's pretty much it. You could do a more careful analysis, but long story short, the range of hyperbolic tangent is minus 1 to 1 not included. And for that reason, this identity only holds for minus 1 less than x less than 1. If you look at section 7.8, oh man, tell me he doesn't have it there. Maybe it's in section 7.9. Oh, come on, man. Just let me down. Oh, in terms of 7.9, there's still one thing I should try to work through with you guys. These formulas in theorem 7.9.2, they're non-obvious, and we should talk about those tomorrow most likely. All right, so that's on page 394 of this thing. Or if you've got the blue book, it's the last hyperbolic section. But anyway, I don't know where the, I'm not seeing the formula I'm looking for right off. Maybe he's got maybe I'm ahead. I follow my heart sometimes, not the book, you know? Forgive me. If you want, I mean, that's kind of weird. I mean, right? Because this formula still makes sense for x beyond there, right? What about x like 1.2 or x minus 3? This integrand is still continuous over there, right? So what do you think happens out there? If I remember right, I think there's another formula which says that it's actually equal to, but we'll have to check me on this because I can't find it in the book right off. But I believe it's the hyperbolic cough. That's for the absolute value of x greater than 1. This can also be captured in terms of the absolute value of x being less than 1. If the absolute value of x is equal to 1, that's plus or minus 1. Those are the points where the integrand's not defined. All right. Well, it's been a long day, but I hope you have some better sense of what a trigonometric function is and also what this wild world of hyperbolic trigonometry is. Tomorrow, I'll take any questions you happen to have about these sections we just covered. I'm hoping to post the solutions to the homework tonight if I don't fall asleep too soon. I was going to do it last night, but then I just fell asleep at some point. And, come on, where's my stupid syllabus? Oh, your quiz, I was going to get back to you.